Hello everyone. Today I am going to discuss on features engineering in data science and machine learning. Feature engineering is a very important thing in machine learning, obviously in data science. To build a machine learning model, choosing the correct algorithm very important. At the same time, good feature engineering also similar important because without good feature engineering or good features, you cannot create a good machine learning model. Like is this scenario kind of like you try you create building your your house, okay, and you hired a world most popular architect, um, builder, but you supply very poor house building materials. What will happen? Your building will fall, right? The same thing happens if you use very good algorithm, but your features in the data set is very poor. So definitely your model will fail. So let's start. As I said, if EDA is the heart of data science, EDA means exploratory data analysis. Then the feature engineering is the brain. Many real-world ML projects succeeded not because of better algorithm, but because of better features. A common saying among Kaggle grandmasters like better features beat better algorithms. Okay. So what is feature engineering? Feature engineering is the process of creating new features, transforming existing features, selecting useful features, and removing useless features to improve the model performance. So, for example, you have data set like it's a house price prediction data set. This is very small. For example, we are taking the area and bedroom value. Okay, so from the data set we can create one new feature like area per bedroom. So now data set looks like this. Let's simply think if you predict price based on the area or bedroom, and now predicting price based on all these three at features, I mean along with the new features, so it will better predict your price, right? Now why feature engineering is needed? Same thing I'm repeating. Suppose we have this data set: house, area, bedrooms, price column. But here you can see the area of the both house is same, but price is different because bedroom number of bedroom is different. So that means both house have the that means layout is different for the both house. So actually feature engineering helps expose the hidden pattern. So you have to analyze the data set and you need to find out what new features we can add so that our model can train or and find the hidden pattern. So in that case, if we add these new features, area per bedroom, then it will clearly understandable by the features. Sorry, by the machine learning model, right? So now professional feature engineering workflow is like that. Start with raw data, then have to understand the business, create features, transform the features, because transformation also very important, because the different features value have in different scale, so you need to normalize it, or I mean you need to standardize it so that all the values in the same scale, so that model can understand every feature, and select features, and finally train your model. So now start with the first step, the understanding the business problem. Actually, you have data, then actually first step start from this here. These are first step, then PHP, second step, third step, fourth, and fifth. So first is understand the business. So before creating features, ask yourself what affect the target. For example, house price prediction. Here target is the price. Then possible drivers means features we can affect the price, like area, location, bedroom, age, okay, and many more. But here I am taking only uh, this small number of features. So business understanding always come first, because without understanding the business, you cannot create good data set, and obviously the model will fail. Now next step is the understanding the existing feature. Very important. Without understanding the every feature, you cannot uh, analyze it, that whether we can create new features or not, whether it is feature associated with the target or not. Okay, which are important, which are not important. So this thing we can actually helps to identify. So what does each column represent? Many beginners skip this, definitely. Actually, this is a very big mistake, as I said. Now, step three is to create derived features. I mean, new features from the existing features. The most common feature engineering technique is that creating new feature. So, as I said before, that from this second data set, we have created area per bedroom. So, this is actually our derived feature. Now, the data looks better. Why? Because capture room spaciousness in the dataset. Depend on the area of the bedroom or space of the room. Definitely, the price will be very bigger space. Obviously, have bigger price, right? Now, another example you can say date time feature engineering. Also, it's a common industrial problem. So, suppose purchase date is this. Actually, this raw purchase is actually sometimes actually not give you the good, I mean, meaningful information. If we break this date like into year, month, day, weekday, so it will be more useful to the ML model, because from this data set you can predict customer behavior, based on the month, season, or day of the week. Okay. For example, e-commerce says the weekend, weekdays, when is actually high, when is low. So based on this data set, the e-commerce team can take the decision. Another example is the age feature. What is it? Also very common thing. Suppose original date is this. Okay, the date of birth. So we can create custom age like by just subtracting the current year minus purchase year. Okay. Actually, here I was talking about the house price, not a date of birth. I was wrong. This is when house was built. Okay. So the custom age is like now if you provide the number without giving the provide the date of the creation, it is more helpful to understand. Okay, right? Also, another example is the categorical feature engineering. ML model cannot understand text, need conversion, right? For example, city like Mumbai. Okay, so we can encode this value like this for city Mumbai 1, for Kolkata 0, and so on. Because model works with number, not with the text. And if we provide number value, then model can understand and detect the pattern easily. Now binding. What is this? Is a convert continuous value into category. Useful when relationship is non-linear. Create young, middle, senior like this. So we can create a group this kind of for this kind of data like young, middle, old, or senior, whatever. So compared to age, the group is more understanding when the value is non-linear. Relationship is non-linear. Log transformation. What is used for skew data? Actually, we have already discussed what is log transformation. If there is a skewness, very high, sorry, not skew, skew, obviously skew, yes, or huge outliers present in your data set, we can use log transformation to normalize the or standardize the value. Like, for example, suppose your value set is like this. You can say the last value is very, very high. So if you train with this raw data, definitely your model will be biased to the this bigger value. So instead of this, we can convert this value into another scale using log transformation so that all the value looks like similar, and it obviously it will reduce the skewness, and as a result your model will be trained properly, not only biased to the any specific or a higher value. Now interaction features, what is very powerful, captures combined effect like area, location, area by into location. We can create area location. Location means actually location score. Actually, locations is like for the city wise. Uh, Suppose, for example, in Mumbai there is a house, and Kolkata there is a house, which is costlier. Obviously, Mumbai. So we can score the Mumbai higher value and Kolkata a lower value. So this type of location score I want to mean. So area into location score, we can create multiply area with the location score. We can create a location area feature. So that our model can understand, uh, I mean, the hidden pattern, how the location area with the price. Now the polynomial features used when the relationship are non-linear in linear regression forecasting is useful. Okay, so from the area we can create area square, area cube like this. I'll discuss separately. I'll create a separate tutorial for these polynomial features. Okay, later on. Then is aggregation feature. This is very common in industry. So customers transactions. So customer A have 100, 200, 300 transactions. Okay. The total spend is 600. Average spend 200. Transaction count 3. So we can create this type of three different this type of features as well in your data set. Okay. So it will help the model to identify the hidden pattern. Text feature engineering. In NLP project, reviewing the amazing product, so we can add word count, TA by DF, embedding. Modern AI use BART, OpenAI embedding, sentence transformation. Okay. Feature scaling, well, already discussed. Actually, to make the value in the same scale between 0 to 1. Feature selection also important because all the features in the dataset not useful. If we keep the unnecessary, not less, actually, the features here don't have any impact to the target feature value. So if we keep those features in your dataset and train your model with this dataset, definitely your model will be confused. So better remove those. I mean, these less important features or useless features to remove the noise from the model. Different way is available to remove those unnecessary features. We already shown in the previous lecture. Detect data leakage. We already discussed. Again, saying so critical step, very important. Suppose your in-house price prediction model, your aim is is to predict the price of the house, but in your dataset itself contains in a dataset which actually you going to use to train your data. This value is present, price is present with another name as a feature. So this kind of information is called data leakage. That means model know the answer. So we need to remove redundant column or feature from data set. Next is domain specific feature. This is where senior data scientists find that domain knowledge creates winning features. So banking, we can debt to income ratio. In retail, we can average basket size. In telecom industry, we can calls per day. So some domain specific, if you have a good domain knowledge, we can you can also create some domain specific new features. That's very helpful to train your model. So real house price, for example, this is a data set, and for the data set, we can create new features like area per bedroom, area per bathroom, total room, house age, luxury score. So this type of new features we can add in a data set. Okay. So the professional feature engineering checklist is understand the business, analyze existing feature, create derived feature, date features, age features, encoded categories, handle skewness, interaction features, polynomial features, aggregations, feature scaling, feature selection, leakage check, domain specific features. All are in the part of the feature engineering. So feature engineering is the process of creating, transforming, selecting, and optimizing features from raw data to improve machine learning model performance. So feature engineering equals to turning raw data into smarter data for machine learning. To create a good ML model, you have to prioritize features, then algorithm. Algorithm also important, but features very, very more important. So thank you for that's all for today.